Okay, this is still section 5.1, finishing up our notes here. Now my directions say find all solutions. So on the last example, we were just finding it one time around the circle. Now we're finding it if I go around a whole bunch of times in both directions. Okay, -2 cosine squared x plus sine x is equal to a -1. It doesn't really matter how you start this. You know that you're solving, so you can set equal to 0 right off the bat. One thing that I like to do is I have two different trig functions going on in this problem, and that kind of confuses me sometimes. So if I can eliminate it so I can get it down to one trig function, I'm going to do that. So where it says cosine squared x, I'm going to replace that with my Pythagorean identity. So everything else stays exactly the same. I just replace cosine squared x. Next step, we can set equal to 0 now. And then after that, I would distribute through my -2. Now, any of these steps can be switched with the other step. It really doesn't matter what order you put these in. It's more of a comfort zone for you. Which one do you want to do first? But no matter what, you should get to where we are right now with a -2 plus 2 sine squared x plus sine x plus 1 equals 0. So the next thing that I'm going to do is just combine like terms and write this in proper order. So it should turn into 2 sine squared x plus sine x minus 1 equals 0. This is a lot easier visually for me to deal with because now I just have one trig function. And this technically is just a trinomial. And remember, we can always replace the sine x's with another variable if you need to so you can see it. So I could treat this like 2w squared plus w minus 1 equals 0. This trinomial does not intimidate you. We have the option to factor. We could do quadratic formula, or I could complete the square on this. Since this one is pretty easy to do, this one's going to factor pretty easy, and I'm just going to use trial and error because the 2 is prime, so I know that 2w has to go to the front of 1, and 1w has to go to the front of the other one. And then my -1, the only factors of -1 are 1 and -1. So I know both 1s will go in there. Now the only thing I have to figure out is which parenthesis gets the plus sign and which one gets the minus sign. So remember, when we're doing trial and error, we're just thinking in terms of if I multiply those two together and I multiply these two together, when I add them, I want to get that +1 right here. So that's what I'm looking for. So when I multiply the inside 2, I get 1w. When I multiply the outside 2, I get 2w. I know one of them has to be positive and one of them negative. And the only way for me to get a +1 when I add these is to give that middle guy the negative. So I know that the negative sign is going to go there, and the positive sign goes there. And I can factor like normal from here. Solve it up, you're good to go. Now, if we're choosing to do it without replacing and just go into our factors, it would be 2 sine x minus 1 and sine x plus 1. That's how it's going to factor, which is pretty much the same thing that we had when we did substitution. Okay, everything is factored. Set both of them equal to 0 and solve. So I'm going to give you a second here to go ahead and solve your problems. Well, this math problem anyway. So on the first part here, I'm going to add 1 and then divide both sides by 2. So you need to think to yourself, where on the unit circle does sine x equal 1/2? And we didn't really have any given restrictions on this one because it asked for all the solutions. So y is equal to 1/2 at pi over 6, and again at 5 pi over 6. Now the difference is that on the last problem it just said go around the unit circle once. So if I was just going around the unit circle once, 5, 6, and 5 pi over 6 would be my answers. But the directions said all solutions, which means I can go around left or right, doesn't matter, clockwise or counterclockwise, multiple times. And so sometimes we would have seen plus or minus 2n pi, where n are the integers. That just means we're going around the circle more than once, or we have the potential to do that. Okay, stepping over to the second part of our problem here. Sine x plus 1 is equal to 0. So again, I'm just going to solve for sine x. Sorry. Where on my unit circle is sine x going to equal a negative 1? So where is y equal to a negative 1 on our unit circle? And hopefully you remember that is at the bottom of the circle, 3 pi over 2. And again, because the directions said all solutions, we would do 3 pi over 2 plus or minus n times 2 pi, where n is the integers. So the one thing that people usually miss on our upcoming assessment is they don't read the directions. Am I restricted to one time around the circle, or does it say all, where I could go around as many times as I need to? Anytime it says all, you're going to want to put the plus or minus 2n pi or n2 pi, whatever, and then n is integers.